Hi, welcome to 10.2. Now we're going to go ahead and talk about triangles. And on page 94, okay, you see a nice little chart of all the different names we have for triangles, okay, and some rules about them. But the big thing to know about triangles is the sum of their angles, that's their interior angles, is equal to 180 degrees. Okay, so that allows us to go ahead and find a lot of things with our triangles. Okay, so I'm going to go ahead and again, just like the previous section and most of the sections here that give you a lot of information, I'm only going to work some examples. I'm not going to go and explain all the little pieces, but you're more than welcome to, if you need a little more, to go ahead and look at the videos that are posted in through Pearson and under your supplementary materials. Okay, I'm going to start off with example 1. And this is on page 95, the next page here. In example 1, I'm going to try to draw this as best I can. I'm not a big artist here. Okay, and I have a line here. Okay, they tell me this is a right angle. Okay, and I have 1, 2. This angle is 36 degrees, the inside. Okay. I have a 3, a 4, a 5, and this angle here inside is 58 degrees because I didn't give myself enough space. Okay, and I'm asked to find the measures of angles 1 through 5. Okay, one thing I do know, if the measure of angle 1, I know that box means that it's that this angle here is 90 degrees. Which means below that line, because it's a straight line, because it's 90 degrees, that angle 1 must also be equal to 90 degrees. This is your starting point. So if this is 90 degrees, so is this. Okay? Now I also know that this angle is 36 degrees right here. So this angle is 36 degrees. Okay? Which means to find the measure of angle 2, I know that the sum of these 3 angles, 1, 2, and 36, have to be equal to 180. Okay? So I know angle 1 is 90. I'm given an angle that's 36. And I'm looking for angle 2. I'm going to call angle 2x. They must add up to 180. Okay? So when I go ahead and figure out this one, I end up with 54 degrees. Okay, when I do that math. Okay, if this is these are both 90-degree angles, which means this is a parallel line, which means if angle 2 is 54, the measure of angle 3 is also 54. All right. Now I have angle 3, and I need angle 4 over here. Okay. The measure of angle 4, again, the sums of the triangle here has to be equal to 180. So I have 54 degrees from angle 3. I have 58 degrees, which was given to me. And I'm going to call for y. You don't have to call me anything different. I'm just doing that. They have to be equal to 180. Okay. So when I go ahead and do the math for angle 4, I end up with 68 degrees. Now all I have to do is find angle 5. Okay, and I know that the sum of 4 plus 5 needs to be equal to 180. That's my rule for angles. Okay, so I know that the measure of angle 5 is going to be equal to 180 degrees minus the angle of of 4. Okay, and I go ahead and do that quick subtraction. It is 112 degrees. So I have found 1 through 5. Okay, and the same thing will work for example 2. Only they didn't draw a line, they just drew a box, but you are given a 90-degree angle on that, so I would love you to give it a try. It's the exact same thing that we just did here. Okay, now we got scale drawings of triangles, and I want to look a little bit at page 96. Okay, and I know with page 96, when we have angles that are the same, not to scale necessarily, okay? If I do by something like this, that tells me no matter what, those two angles are the same. Okay, it's not a box, it didn't draw a 90-degree angle. If they have matching lines in the same places, even if they're different sizes, they can go ahead and we know those angles are the same. Okay, and if those angles are the same, no matter what the lengths are, they're proportional. Which means we can go ahead and use the idea of proportions to go ahead and solve it. For those of you that have forgotten what proportions are, it is a fraction that is equal to another fraction. And the good thing about these is when we're solving them, we can cross multiply. And that's the easiest way to go ahead and deal with these types of angles here. Okay, so I'm going to go ahead and look at example 3. All right, and I'm going to go ahead and draw as best I can. Okay. We have two right angles. We have a 10 centimeter, an 8 centimeter, an X, and a 12 centimeter. Now this might look kind of confusing because they've got it all mirrored and whatever, but these two angles right here and here are the same. All right. We also know that because of this, these other angles must be the same here, which means those angles are the same here, which means these are proportional. So our matching sides, now remember we got to go off what we were given. Our matching sides are this and this one, because this triangle can be flipped and turned, okay? This here, this and this one are the similar sides. Remember, we want our triangles, just because I have one facing this way, this one is, the other one is facing like this. Okay, which means this one here can be turned around to where this angle here is now here. Okay. Once those angles are in the same spot, we know what sides match, that this side matches this side. All right. So I'm going to set this up as a proportion. So my proportional sides in red are 8 and 12. And notice I'm not going to worry about the units. The units are still going to be centimeters. And that's going to be equal to, now I want to keep the side that matches this that I'm given with that number. Okay? So I want to go ahead and make sure my 10 ends up here. Okay, which means my last piece, my X, ends up here, which I'm solving for. Now we're allowed to cross multiply. So we multiply those two and I get 8x. I multiply 12 times 10 is equal to 120. The equal sign still stays in between. And then if I divide 120 by 8, I get x is equal to 15. And now I put the centimeters back on. And so the proportional side is 15 centimeters. Okay. So I know visually this is a little bit harder for some people to see, but remember you can rotate these triangles. You just want to find the angles that match. Okay. I'm also going to go ahead and look at one of the picture problems, which are on 97. All right. And I'm going to go ahead and do example 5. Okay, so for example 5, I have the height of a lookout tower. Don't judge my lookout tower, okay? Is shown in the figure with the lines at the top of the tower, okay? They're calling this H, okay? We are 2 yards. So we draw 2 yards. Okay, they draw it like this. And they say this length is 56. Okay. It is a stick that's 2 yards long and 3.5 yards from the line to the top of the tower. Okay. So I have this extra line here. Okay, they're just kind of drawing it. It's 3.5. And they're saying that there's a stick coming up here. That's 2. Okay, what they're trying to do here is create similar triangles by having a smaller piece here and a bigger piece here. Okay, and what they went ahead and gave us is proportional. So for the bigger triangle, I have this side. And the bottom of the similar triangle is right here. Okay, so that's going to create a proportion. It doesn't matter where you put them as long as you're consistent. Okay, so I know that I'm going to go ahead. I'm going to use I know my 3.5 and my 56 are both bottoms. Okay, they're both the bottom of the triangle. I also know then my 3.5 here goes with this 2 here. So my 2 I'm going to put on top. The last piece that's missing is our height or our h. You can call it h, you can call it x, it doesn't matter. Okay, and then I just have to cross multiply. All right, so I have 3.5h from cross multiplying this direction. When I cross multiply the other direction, I go ahead and I get 112. And then if I go ahead and divide by 3.5, h is equal to 32. Everything is in yards, so I need to write yards on there. Okay, we're using the same idea here as we did with the similar triangles that were in example 3. Right? But now they just kind of drew a picture, and they did the same kind of picture in example 6. And it's probably a lot easier to read than the one that's in example 5, which is why I did example 5. Okay, so go ahead and make sure that you're trying that. Make sure that also for example 6, you might want to round. Okay, because you're going to find something happening with that one there. Okay. The last piece of 10.2 is something called the Pythagorean theorem. Okay, and the Pythagorean theorem only works with right triangles. Which means we have to have a 90-degree angle involved. Okay, so if I have a right triangle, There's my 90-degree angle, okay? And we got a formula. Some of you may already know it. Some of you may have seen it and forgotten about it. Is a squared plus b squared is equal to c squared. A and B represent your legs. And it doesn't matter who's who, but your legs are the sides right next to your 90-degree angle. Okay. Your c squared is something called a hypotenuse. Okay. Which will always be your longest side. Okay. So I'm going to go ahead and do example 7. Okay. And I'm going to leave the rest of them for you. But like I said, if you ever have any questions, want me to work them out, I could totally do that. But I'm going to look at example 7. Okay. And I want to find the length of a hypotenuse in the right triangle whose legs are 7 and 24 feet. Okay. Which means if I were to go ahead and draw this, and draw my 90-degree angle, one of them is 7, one is 24, and they must be right on the side of, right next to my right angle. They have to be those pieces. And I'm looking for this piece here. Okay, now it's up to you whether you want to continue to call the hypotenuse C or not. Okay, it's really up to you. I just use X. You can use C. You can use whatever you would like. You want to keep the letters the same, fine. Okay, so I have 24 squared plus 7 squared. Doesn't matter which one you use, they're interchangeable. You could do 7 squared first and 24 next, is equal to x squared, or my c squared. Okay, when I go ahead and do the math for it, I have 576 plus 49 is equal to x squared. When I add those together, I get 625 is equal to x squared. Now, in order to solve for x squared, the opposite of squaring something is to take the square root. So I need to take the square root on both sides. Okay? If I take the square root on both sides, I get x is equal to 25, and it is in feet. Okay? So your square root button is on your calculator. If you need to take the square root of a number, you hit the blue key or the second key, and it is hit the x squared button because in blue you see the square root. Okay, and then if you want to, you could just type your number in that square root and it'll give you your 25. Okay, so that is the end of 10.2. See you back for 10.3.